everyone, welcome to hok'stutoring. I hope you're having a great day. Today we are doing chapter 60, question 5. Right, so this is your differentiation chapter, and more specifically it's your second derivative topic. Okay, so this question is pretty straightforward. As you can see, it's only one line question, but it is quite confusing when you actually go through the exercise. So I just want to get through it, and hopefully you find this video useful. Let's go. If y equals to e to the power of sine inverse of x, so yes, we know how to differentiate both of these, hopefully. Show that 1 minus x squared times the second derivative minus x times the first derivative minus y equals to 0. So it's a show question, it's a proof question. And if you want to do this, you always have to go one side equals to the other side. And in this case, it's pretty clear that you have to go left to right and not right to left. You can't change 0 into some, just the left hand side, because you can't do anything with 0, right? So you have to go left to right. Let's have a look. There's a second derivative and there's the first derivative. We don't have that yet, so we have to find it for us to solve this question. So let's do some derivatives. So dy dx, how would you find the first derivative? That is just deriving the exponential right here. And exponential, if you were to derive them, this is the form. d dx of e to the power of fx, we get f dash x times e to the power of fx, okay? So we have to derive sine inverse, bring it down, we get f dash x, and then it's just the original. Okay, so let's derive sine inverse first. If you are deriving sine inverse, well, we know the formula, once again, d dx of sine inverse of x over a, essentially, is 1 over square root a square minus a square, okay? So that's the general formula. And we get the same thing here. Now a is just 1 because that's sine inverse of x over 1, so a squared is still 1, and that's 1 minus x squared, multiplied by e sine inverse of x. So nothing has changed. It's still the same, e sine inverse of x. So that's dy dx. I'm just going to write it in a form so that's easier for us to derive the next one. Just put them over a fraction. And then let's find the second derivative. So d squared y dx squared. How would we solve for that? Well, we have a function over another function. This is a case of quotient rule. So we have to apply that over here. And for quotient rule, if you're deriving d dx, so let's see, fx over gx, then we have f dash x times gx by itself, minus fx times g dash x instead, so derivative of g, and then everything is over gx fully squared. So let's apply this over here. F dash x is the one on top, so fx is the one on top, gx is the one at the bottom. So we have to derive this again, e sine inverse of x. We already know what that is, and that is 1, actually I'll just write it, e sine inverse of x over square root 1 minus x squared. So that's what we have here. I'll put a bracket so you can see it. And then everything's going to be divided by something. Okay, so this is the derivative of fx, okay? So we get f dash x. This is just f dash x, this part right here. So that's done. Now we have to go through gx. And then now we just put gx, which is multiplied by root of 1 minus x squared, okay? Because gx is just the function at the bottom, which is this, okay? And that solves the second part. Moving on to the next stages, that is fx and g times by g dash x. Well, fx is just e sine inverse of x. Nothing has changed here. E sine inverse of x multiplied by g dash x, okay? So g dash x is we derived the function at the bottom. The function at the bottom, another way of writing that is 1 minus x squared to the power of half. And if we were to derive that, we bring half down, we bring the power down, minus the power by 1 times by derivative inside. So chain rule pretty much. Half 1 minus x squared, half minus 1 is negative half, times by the derivative of the inside, that is negative 2x. And if we simplify that, we get negative x over square root 1 minus x squared. Okay, so we multiply that by that right here, 1 minus x squared, okay? And that finishes the function on top, okay? So that is that. And then gx fully squared, this is not quite nice because we already have the square root here. So if you square that, it disappears. And you're left with 1 minus x squared. And now it's just a case of simplifying. D squared y dx squared, what do we get? Well, this cancels out conveniently. And we're left with e sine inverse of x minus minus actually, plus, because negative times negative x is plus x, e sine inverse of x, and then everything is divided by 1 minus x squared under the square root, okay? Now put that inside the bracket again so you don't get confused or lost, because it's a fraction over a fraction, and then this is still 1 minus x squared, and then we keep going through this. Okay, we have to get rid of this denominator because a fraction over a fraction is very confusing. So to get rid of this, we make the top part have the same common denominator. So if you want to do that, you have to multiply the first term by root 1 minus x squared as well. So we get root 1 minus x squared e sine inverse of x plus x e sine inverse of x, okay? And then everything is going to be divided by 1 minus x squared under the square root. Right, and the good thing is, if you have this over here and then everything over here is divided by 1 minus x squared, you can bring 1 minus x squared, or you can bring the square root down as well, okay? So that's pretty much it. You end up with this as your function for second derivative, d squared y dx squared. Now let's move on to the next stage, and that is just plugging everything inside this equation right here, or the left hand side, to prove that is equal to 0, which is the right hand side. Okay, 1 minus x squared, I'll just write that down. Again, 1 minus x squared d squared y dx squared, and then it is minus x times dy dx, and then it is minus y equals to 0. Okay, we know that the second derivative is this big fat term right here, or this expression right here, and then dy dx is that expression up here. So we can just write that down first, fill in everything, 1 minus x squared times by the second derivative, which in this case is that, and I'll just write that down, 1, so square root 1 minus x squared e to the power of sine inverse of x plus x e sine inverse of x, everything divided by 1 minus x squared in the bracket multiplied by square root of 1 minus x squared, okay? So that is that. And then we also have minus x times dy dx. What is dy dx? Well, dy dx is what we found in the first place, e sine inverse of x divided by the square root. So I'll just write that down, minus x times e sine inverse of x divided by the square root of 1 minus x squared. Okay, and then minus y. What is y? Well, y is e sine inverse of x. So that's what we had in the what they gave us. Okay, so up here, y equals to e sine inverse of x. Okay, right. So that's what left hand side is. Let's try to make it equal to 0. So cancel some things out. 1 minus x squared, 1 minus x squared, and you're left with just this term right here divided by square root 1 minus x squared. And I'll write that down, 1 minus x squared e sine inverse of x plus x e sine inverse of x, everything divided by square root 1 minus x squared, and then it's minus x again times e sine inverse of x, everything divided by square root 1 minus x squared minus e sine inverse of x, guys, and we're almost done. Now, okay, so these first two terms, or these two fractions, have the same common denominator, so you can add, subtract normally. And what you can see is that's a plus x e sine inverse x, and that's a negative x e sine inverse of x, so they cancel out. And what you're left with is this right here, square root 1 minus x squared e sine inverse of x, and that is divided by, so the denominator is square root 1 minus x squared, okay? And this pretty much just disappears because it's the same common denominator, okay? So just combining them together, okay? I can just put a cross here, okay? And that's a minus. Right, and then that's minus e sine inverse of x, and you can already see it, hopefully. So this cancels out, root 1 minus x squared divided by root 1 minus x squared, and you're left with e sine inverse of x minus e sine inverse of x, which gives us a 0. Okay, guys, so that is how you solve for this question. So it's quite confusing, it's a long process,
but as long as you diff them step by step, you should be fine, okay? So that's pretty much it, guys, for question 5 from chapter 60. Hope you found it useful, and I'll see you in the next video.